Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad HAFIZURRAHMAN bin ZAMRI, and today I will explain about the hybrid renewable energy system between solar energy and fuel cell. For the introduction, global energy demand is increasing every year, driving research and development into alternative renewable energy resource and combination of renewable energy. This is because the system are environmentally friendly compared to conventional energy. The combination of renewable energy source is known as hybrid renewable energy system. This system is widely used around the world. What is hybrid renewable energy system? A hybrid renewable energy system is a combination of two or more renewable energy source. There are some examples of hybrid renewable energy systems such as solar energy and wind turbine, solar energy and hydroelectric, wind turbine and battery storage, and lastly, solar energy and fuel cell. The main purpose of this hybrid system is to provide a consistent source of electricity without depending only one source. Hybrid solar energy and fuel cell. What it is? A hybrid solar energy and fuel cell system is a combination of a solar energy system and fuel cell system that generates electricity from the sun energy and from chemical reaction. Solar panel array is used to generate electricity from the sun during the day, and the fuel cell generate electricity at night or during cloudy day or when the solar panel are not producing as much electricity. So our group propose this type of hybrid system to the water pump application. How it works? The hybrid solar energy and fuel cell generate the electricity energy to pump the water from a source to the destination. The solar energy can be used to pump the water during the day when the sun is shining, and the fuel cell will continue generate the electricity to pump the water during night, day or cloudy day. This system will be automatically switched between using solar power or fuel cell power depending on the availability of sun and fuel level to ensuring water pumping continue pump the water. Last but not least, how the solar PV get the energy. The solar PV get the energy from the sun releasing a large amount of energy. This energy travel through the space and reach the earth's surface as the sunlight. The solar PV is designed to capture this energy and convert it to electricity using the photovoltaic effect. The photon from sun hit the solar panel and absorbed by semiconductor material and creating the electrical energy. That's all for me. Thank you very much. I will pass to our friend Mohamad ZAKWAN. Thank you.
Thank you, HAFIZURRAHMAN. Assalamualaikum and hi. My name is Mohamad bin Anwar. This section I will explain about how the resources is obtained and converted. First, we have a solar PV. Solar PV system use cell to convert sunlight into electricity. The PV cell is made up for 1-2 layers of a semiconductive substance, usually silicon. When sunlight hits the cell, an electric field is formed across the layers, causing electricity to flow. The greater the intensity of the light, the greater the flow of electricity. Then, fuel cell function similar to batteries, except usually do not need to be recharged. A fuel cell is made up of 2 electrodes, one negative or anode we call, and one positive or cathode we call it, sandwiched by an electrolyte. A catalyst at the anode of her hydrogen fuel cell split hydrogen molecules into protons and electrons, which travel in the opposite direction to the cathode. Hybrid system is that combine a stand-alone PV solar system and a fuel cell can provide a reliable and efficient source of renewable energy. Together, these two sources of energy can provide a consistent and dependable power supply. The PV solar system can provide electricity during the day when sunlight is available, while the fuel cell can provide power at night or during periods of low sunlight. The fuel cell can act as a backup power source in case the PV solar system is not able to generate enough power, such as during cloudy weather. Next, how the hybrid system is converted. A hybrid system that combines fuel cell with solar PV converters is a form of renewable energy system that generates power using numerous technologies. Fuel cells create energy using a chemical reaction, typically by turning hydrogen and oxygen into water and releasing electricity as a byproduct. Solar PV transforms sunlight into electricity using the photovoltaic effect, which involves the use of semiconductor materials to convert the energy in sunlight into electrical energy. The fuel cell and solar PV are linked to an inverter in hybrid system, which converts the direct current power generated by the fuel cell and solar PV into alternating current. But this is only an option because this project does not use an inverter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hashimi bin Mohamed Imran. Today I want to talk about the design for our hybrid system, which is fuel cell and solar power system designed for water pumping application. The main component for this design is solar PV and hydrogen fuel cell. The primary component that make up the solar PV panel are the solar cell. The configuration provide the one diode equivalent model for a single solar cell parameter. Along with a diode and current source, the circuit also has two resistors. Next, the hydrogen fuel cell use the chemical energy that is produced from the reaction between fuel, hydrogen and oxidizer result in obtaining electrical energy. Next is the flowchart of the operating system. Okay, we start with the PV system with MPPT component. Next, the energy we transfer to voltage regulator and electrolyzer, and then throughout the battery bank and the DC motor and pump. And then the energy to battery bank we transfer to the fuse logic management, and the energy we transfer from the fuse logic management throughout the hydrogen storage tank and fuel cell. Next, it will pump out the water through the DC motor and the fuel cell. Okay, next, the solar system block involving MPPT and forecasting system. Okay, a natural network block has three main input which are connected to stair generator block. Each one of these block has either temperature value in Celsius, wind speed or humidity percentage. Additional block which hold the temperature value is connected to the solar PV panel block. Okay, next is voltage regulator and DC water pumping. For voltage regulator, is used in hybrid system to set the solar panel voltage for the battery charging to a value that is close to 12 volt. 3 resistor and operation amplifier, a transistor and a diode make up the voltage regulator. Next is the DC water pumping motor. The fuel cell generate output voltage at their output terminal. The state of charge of the battery bank directly affected the fuel flow. And then lastly, the motor and driver, main block, manual switch, measurement block and switch block for reverse and brake make up the DC water pump system. Okay, this is the circuit diagram for voltage regulator and DC water pumping. Okay, that's all for me. Next, I will pass to Mohamad AL-BUKHARI.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Al-Bukhari bin Mohamed. So this section I will be explain about implementation of solar PV with fuel cell in Malaysia compared with other country. So based on the recent development, the study of hydrogen has received significant attention from several Malaysian universities, particularly in the area of fuel cells. There are two pictures depicted in this slide, which is first picture shows that the H2 motif, a motorcycle powered by hydrogen fuel cells by University Technology Malaysia. The next is the Malaysia's Eco House, the solar PV combining with a fuel cell energy located in University Kebangsaan Malaysia. So hydrogen installed capacity compared from Malaysia with the other world. The hydrogen pathway has been created during the Act Malaysian Plan to support decarbonisation by the end of 2030. In 2005, 1 kilowatt solar PV hydrogen has been completed by using PEM fuel cell. In 2009, first hydrogen refueling system using off-peak electricity operational is completed. The implementation of fuel cell energy in Malaysia is still under development stage compared to other countries. Advancement of water electrolysis has also demonstrated that there will be a number of future electrolysis experts who may be able to offer a clear roadmap for decarbonisation in Malaysia. As illustrated in charts below, shows that country in Malaysia like Southeast Asia has bring a less hydrogen consumption compared to China, Middle East, United States and other countries. So for solar PV installed capacity, Malaysia has actively promoted the use of renewable energy, especially solar energy in terms of resource utilisation. Government has put financial to achieve 20% of energy mix at the end of 2025. However, this is less than other nations with significant solar PV deployment, such as China, Japan and the United States. Potential for massive solar power plant is however constrained by Malaysia's smaller land area. Malaysia's electricity demand is lower than that of those nations. So from this chart, it shows that the implementations of the renewable energy source using the solar PV is higher compared to other renewable energy source. However, it is more or less compared to the other countries such as China, US, Japan, Germany and other countries because of its constrained by smaller land area. So the suitable location for the hybrid system. Solar PV can be installed in any land in Malaysia with the higher photovoltaic power potential. Solar PV with full cell can be implemented in isolated or off-grid location with restricted access to the power grid. So these three example of suitable location where we can be implemented the PV hybrid system. The first location is located at Kampung Sungai Rul Pahang. Next location is Pulau Perhentian Terengganu. The lastly is the Felda Chupeng Perlis. So that's all for me. I hope you enjoy my explanation. Thank you.
Hi, Assalamualaikum. My name is Mohamad bin AZMAN. Now I want to continue on my part, which is about opinion on the energy usage. Electricity generation using hybrid, hydrogen fuel cell and solar PV system has the potential to be very efficient and environmentally friendly. When solar PV systems are unable to produce sufficient electricity, such as at night or on overcast day, hydrogen fuel cells can act as a stable supply of energy. To use energy resources more effectively, hydrogen fuel cells can also be used to store extra energy produced by solar PV systems. Next, about the advantage and disadvantage of solar PV water pumping scheme. First one is about the pros, which is first is low operation cost since fuel is not needed and system run on sunlight. Second, low regular maintenance requirements since solar panel and inverter have no moving parts. And the third one is no dependency on erratic or expensive fuel chain supply. Avoid also the risk of fuel theft. Next, about the cons of the solar PV. First, capital costs typically higher than equivalent diesel solution. However, system prices are increasingly dropping. Second, most of application need water storage typically larger than for equivalent diesel system. And the third one is system is dependent on solar radiation level. Next, about the advantage and disadvantage of hydrogen fuel cell water pumping scheme. First, about the pros. First one is ideal for use in remote area. Second, renewable and readily available. And the third one is highly efficient when compared to other energy source. And about the cons of hydrogen fuel cell is the first one is hydrogen extraction. Second, cost of raw material, and the third one is overall cost. Next, we move on to the next part, which is about the opinion on the energy impact to the economic, social, and environment. Okay, next, economic impact. First is for a more continuous and dependable source of power, hydrogen fuel cells can be utilized to store energy produced by solar photovoltaic (PV). Second, the usage of hydrogen as a fuel source can also be lessened. The use of fossil fuel, which may have positive economic consequences, including lower fuel import costs and lower greenhouse gas emission. And the last one is overall, it is thought that a more sustainable and financially feasible energy system might be achieved by combining solar PV and hydrogen fuel cells. Next, social impact. First, when solar PV alone will not be sufficient, such as when there is little sunlight or a strong demand for electricity, fuel cell can offer a dependable source of power. Second, in addition, compared to a conventional fossil fuel, hydrogen fuel cell don't emit any greenhouse gases, making them a cleaner energy source. And the last one is the infrastructure for producing, storing, and distributing hydrogen must be present for this system to be effective. And the last one is environment impact. First, when coupled with solar PV, hydrogen fuel cells may rely on clean, renewable energy source without emitting any detrimental greenhouse gas emission. Second, the source of hydrogen used in the fuel cells will also affect how much of an impact such system would have on the environment. And the one is the overall environmental effect would be significantly reduced if hydrogen were created using renewable energy source such as electrolysis powered by solar PV. And the last one is, however, the most popular way of producing hydrogen by steam methane reformation would still result in CO2 emission that would have an impact on the environment. Okay, that's all from me. Thank you for lending your ears, and I will pass to my friend, which is Mohamad HAFIZURRAHMAN, to conclude about our system. Thank
Thank you
you.
to all my friends. Lastly, for the conclusion, hybrid renewable energy system have the potential to provide a more reliable, efficient and cost-effective source of electricity compared to single-source renewable energy system. By combining different types of renewable energy such as solar energy and fuel cell, it can increase reliability, increasing the efficiency and also cut the cost and more flexibility. Hybrid renewable energy systems are a promising solution to the challenge of transitioning to a cleaner and more sustainable energy future. Thank you so much.